Student practice number 1, we have the integral from, well, the integral is going to be from 0 to 2 because we're going to rotate this region around the x-axis, the line y equals 0. So I always forget to do that. I get kind of lazy when it comes to this part. In fact, I'm going to do these problems the way I would normally do them. So normally I would just draw a disk like this, okay, without doing the reflection. Okay. And then I would also know that the radius of this particular disk, the radius is x squared. Okay. And then I would just go right to it. Where's my blue? So we get the volume is equal to the integral from 0 to 2 of pi r squared dx, because we're integrating from left to right. The volume of one disk is pi r squared, which is the area of the face, and multiplied by the thickness of the disk, which is dx. Okay, so we get 0 to 2 pi x to the 4th dx, and type that into the calculator real quick, and we get, let's see here, we're going to go from 0 to 2, and that's pi times x to the 4th power dx. So you should get 20.106 if I did that correctly. 20.106. Okay? 20.106. Okay, so hopefully you're 1 for 1. Okay, that's 2 minutes. Let's see if I can get all these done in 10 minutes. Number 2, we're rotating this region about the line y equals 0. So we're going to make a rectangle, rotate it around. I think I do better when I'm just kind of doing it on my own, like I normally do. Radius is radical x. Okay? I always write that down though. I usually, well, I always do, because I like to see it, r equals something, before I write it down. So the volume we know is going to go from 0 to 2. Another one from 0 to 2. But we're going to add up an infinite number of disk volumes. So all we have to do is find the volume of one disk. The volume of one disk is pi r squared, and r is radical x, so radical x squared dx. So we go from 0 to 2 of pi x dx, and 0 to 2 of pi x dx is, delete that, and we get 6.283. Approximately equals 6.283. Okay. There you go. So maybe you're fast forwarding through this. That was even less than 2 minutes. These ones take a little longer. We're rotating this particular region around the line x equals -1. So x equals -1 is that line right there. And so drawing a horizontal rectangle, oops, paper moved on me. Horizontal rectangle, we're going to rotate that rectangle around somewhere over there. Okay. Yeah, my left to right rectangles are not nearly what I like them to be, like my other ones are. Nevertheless, there's our disk. Always seems to have a little higher side on the left. And the radius of the disk, again, this is your bread and butter right here. This is the, you get this part right, your success rate goes way up. The right side is y equals, okay, so we're going to have to make a little conversion here. We're integrating with respect to y. So always think through what you're doing. Okay, y equals radical 3 minus x, and so we're going to square both sides. We're going to add x to one side, to both sides, and then we're going to subtract y squared on both sides. So this curve right here is your 3 minus y squared, x equals. Okay? And 3 minus y squared is the right side of that line segment, and the left side of the line segment is negative 1. Okay, well, where does this end? We're going to go from 0. We're going to integrate from 0 to what? Well, how do we know what the y value is if we know the x value? Well, to get the y value, if you know the x value, is you plug in the x value. Let's plug it into the original equation. If we know x, y equals the square root of 3 minus the x value. So we know the x value, and we're going to plug in the x value, and we're going to find the y value. 3 plus 1 is 4, and so we get y is 2. So that's the high point. That's how high these disks will go when you're integrating. You're adding up an infinite number of volumes of disks. They're going to start at 0, and they're going to go all the way to 2. And I didn't put the radius yet. So the radius, see that sitting there, it's probably bothering you, sorry. So the radius is the right curve, 3 minus y squared, minus the left curve, x equals negative 1. Remember, everything is in terms of x. X equals, I should say, x equals 3 minus y squared. Okay, x equals negative 1. So what x is equal to minus what else x is equal to. And so we know that 3 plus 1 is 4. So really, that's equal to 4 minus y squared. Is that what the other one was? I don't remember. Nevertheless, pi times the radius, that's the radius right there, times the radius again squared dy. Okay, so there, we're going to plug that into the calculator, and we get, let's make the y1 equal to 4 minus x squared. Oh man, 4 minus x squared. Okay, so pi times 4 minus x squared, don't forget, squared as well. So that's our y1, and if we integrate, I'm going to insert a y1, okay, dx, and we get 53.617. 53.617. 617. It seems like that number sounds familiar. Are you serious? The same thing as that last one. That's right. Now there I was making up an example that would help you, and you got the same exact thing. Oh well, that's the way it goes. At least we're consistent. Last one. Number 4. Y equals x squared. X equals 0, x equals 2. Okay, you don't even need that x equals 0. Why I bothered putting that there. About the line, oh, it should, you know what, I should have written y equals 0, so my bad on that. Same with that other one. Okay. Well, anyway, we're rotating this region about the line x equals 2, and so we draw our horizontal rectangle. We draw our disk. I do like to make sure I draw the disk because it helps me visualize that radius of the face of the disk. Okay, so the radius is equal to the right curve 2 minus the left curve. So we have this issue again. Y equals x squared, take the square root of both sides, we know it's the positive one, and so this right here is x as a function of y, x equals radical y. So we have 2 minus radical y, that's a radius. Now we're golden. We have our volume, and we're almost golden. So we have 0 is where we're going to start, so we're going to integrate from 0 to what? Well, when x equals 2, y equals 4. So we have the point 2, 4 right there. And so we're going to integrate from 0 to 4, and we have pi times the radius, which is 2 minus radical y, squared pi r squared dy. Okay, and typing that in, this is a cool thing. Let me show you. If you just leave it as, let me see, if you leave it as the integral from 0 to 2 of y1 dx, You just change your y1 and then change your limits of integration. So you don't have to retype that in. Okay, a little tip for you. So again, I'm going to change my y1, leave the pi there, and we have 2 minus, we're going to insert the square root of x. I promised you I'd use the other one, didn't I? Delete, delete. So 2 minus radical x squared. This is where you can evaluate. Am I getting this right? Pi times 2 minus radical x squared. Okay, quit that. And then we can do second entry. We go back and change the limits of integration, and then you're good. And you get the final answer now, 1043. I hope we're good. I won't have to do this one again. 8.378. Okay, 8.378. 8.378. Okay, there you go. We'll see you in class. Good luck to you. And there you go. Have a great night.